We want to determine the convergence of this series. At first glance, we may say, oh, we've got another alternating series, but be careful. This is -1 raised to some nth power, but it's to the 2n. And so this is always going to be an even exponent, and therefore when we multiply this out, this is always going to be a 1. So this is not an alternating series, and in fact this is doing nothing other than maybe trying to trick us here. So we're going to have to use some other kind of a test for determining convergence. Now as I look at this, I can see that, oh, maybe I'd want to compare this to a known series, comparison test. This is the same thing as 2/3 times 1 over n. So if I went to compare that to 1 over n, which I know diverges, this is always less. So the inequality is going the wrong way for using the comparison test, because I know this one diverges and I would have needed to show that these terms are less than these. Since the inequality is going the wrong way, we are going to use the limit comparison. So we're going to look at the limit as n goes to infinity of 2 over 3n over 1 over n. Now let's see what we can do to simplify that. So this would be n over 1, and these would cancel. So the limit as n goes to infinity is 2/3. Now remember the limit comparison test. If this limit is a positive finite number, which it is, 2/3, then either both series converge or both series diverge. So by the limit comparison test, this series diverges.